Hello, so in this video I'm just going to be running through how I converted this simple 240 volt mains AC water heater to run on 12 volt DC. I use it for heating water in my self-converted camper van. But of course it would work perfectly fine in a boat or some sort of off-grid scenario or something like that. So it's quite a simple thing to do. I will of course I suppose do a couple of preemptive warnings. This is not really an instructional video, it's just showing you what I did. You can do whatever you want if you want to do something like this, but obviously, you know, a water heater is a pressure vessel, so if you're modifying it, you should pretty much know what you're doing. Now this modification of this water heater is pretty safe by all accounts. There is no modification or removal or blocking of any of the existing safety features in this water heater, which I'll show you when I go through it. And the other thing, before I open it up and show you what I did, is just to preempt some of the inevitable sort of YouTube keyboard electricians that are undoubtedly going to comment on what I've done here. So I'll just preemptively say that there might be some things you see here that you would find unusual, especially in the fact that I am going to be running DC power through some components that are initially intended to have AC power run through them. Now a lot of people will tell you that oh, you can't run DC through AC appliances because DC and AC arc differently, especially in a contact switching scenario, and things like that. In the worst case scenario, you'll have contact melting, or the best case scenario, you'll have contact carbon buildup and have switch failure and things like that. That can certainly be true if you were taking a 250 volt rated AC switch and for somehow or some reason decided to run 250 volts DC through it. That would be a bad idea in my opinion. But AC rated components running 12 volts, such a low voltage as 12 volts through them, is generally okay. And I'm doing that in a couple of scenarios here, which I'll show you. But you know, this is from my own experience of studying electronic engineering. But again, you know, do your own research, do it as at your own risk. This is just an example of what I'm doing. So without further ado, I'll take this apart and show you what I did. I've already pre-disassembled it. It should come apart pretty easily. Just take the front cover off. Yeah, if I haven't already mentioned, I should mention this is a really bog standard undersink, oversing 15 liter mains water heater. It has a 2 kilowatt 2000 watt heating element that runs on our AC that we have here in Ireland, which is 230 volts nominal, 50 hertz. And it's just got a simple dial switch at the front, which goes from off to whatever heat level you want to put it to. The max heat that this water heater will get to is 75 degrees Celsius. So take the front plate off. I've already unbolted this. This is obviously the electronics that the back of that dial switch. These are the front LEDs. Power LED and heating LED, and these run to the elements and the thermostatic safety and cutoff devices on this mounting plate here. Now I've already taken the bolts off this, so I can take this out quite easily and show you. This requires a little bit of maneuvering to get the elements to come out. There we go. So on this here, there are two thermostatic cut-offs, safety devices, just to make sure that the water heater doesn't run over temperature, which would be a bad thing. And then this big purple thing here is obviously your 2 kilowatt 40 volt or 230 volt mains AC water heating element that the water heater came from. Now inside that element, excuse me, you will see this silvery colored element here. This is the element I've installed additionally to the mounting plate in this water heater. It is the 300 watt 12 volt DC water heating element. I have mounted it very simply. It comes, you'll see these two threaded rod ends here. It comes with those mounted on the back of it. I've literally drilled through the mounting plate here, put the water heater element through the mounting plate. I have initially secured it in with some high temperature epoxy, which is food safe. It's drinking water safe epoxy, and then I've also additionally sealed it with some high temperature silicon sealant, which is the same type of high temp silicon that you'd use for repairing an engine gasket or something like that. And then it's just secured in place with some nuts and washers to secure it into the mounting plate, and with some electrical spade connectors in it, which has the existing spade connectors from the water heater installed to the end of it. You'll see these two spade connector contacts as well. These are the original ones for the 230 volt element. I've just literally removed those, the contacts around those, and put them onto the other element. So it would be very easy to convert this back to 230 volts. You'd literally take these spade connectors off and put them onto the original element. And that sort of leads me on to what are the electrical modifications on this water heater, which may be surprising to you. There are none. The only modifications to this water heater is installing that 300 watt 12 volt DC water element and changing the spade connectors over, which might surprise some people. So, you know, this is where the 230 volt line and neutral, or live and neutral, depending on what you call it, what part of the world you're in, came in. These are obviously two DC leads now that are coming in with the same spade connectors that I'm connecting into the thermostatic cutoff here. So the original live and neutral for the AC came in here. I'm literally I've taken those plugs out and I'm connecting these to the live and the positive and the negative of the DC connectors in here. And it might surprise you that there are no electronic modifications to this. The LEDs work perfectly fine on the front with 12 volts DC running through them instead of 240 volts AC running through them. The switch works perfectly well in the exact same way, with the DC running through them instead of the AC. Now this switch, this is the back of that knob switch on the front. It is, as stamped on it, as per regulation, it has to say what it is rated for, what it's been tested for. And it is rated for AC 250 volts. Now just because it's rated for that, it doesn't mean that it won't run on DC. It runs perfectly fine on 12 volts DC. As I mentioned previously, it'd be a terrible idea to run 250 volts DC through this. You would encounter problems, but I'm running 12 volts DC through it. And, you know, again, I'm not recommending that you use electronic devices for voltages and currents they're not rated for, but that is what I'm doing here, and my own study of electronic engineering. It's totally fine as long as you're keeping your DC voltage relatively low. And that is basically it. Now your mileage may vary depending on what water heater you get, but that is the sum total of the modifications to this water heater. It was literally a case of drilling out the mounting plate, putting my 230 volt or my 12 volt DC element in, and literally swapping out the contacts, taking out the 230 volt feed and putting in a 12 volt feed, and the water heater works perfectly, and the switches and the LEDs and everything work perfectly. Now obviously I've changed out a 2 kilowatt element for a 300 watt DC element, so the performance will not be the same. You know, whereas if this was water heater was running on AC, you know, it would heat up this 15-liter tank in tens of minutes, up to its max temperature, 75 degrees. Now, if I wanted to heat this water heater up to its max temperature of 75 degrees using my 300 watt DC element, you know, you're probably looking at somewhere between 3 and 3.5 hours if you wanted to get up to the full 75 degrees Celsius from a cold start. That might seem an awfully long time to get 15 liters of hot water, and it is. And, you know, obviously, heating water with electricity is actually incredibly inefficient unless you have free electricity. So in this fan I have 440 amp hours of battery storage, and I also have 400 watts of solar on the roof. So on a clear sunny day, I am often generating more wattage than this water heater can use on full tilt. So it's set up in a way that yes, if I want a tank full of hot water, I might have to wait a couple of hours for it before I can have my shower, but it's, you know, I can be heating up that water and actually be generating extra power into my batteries. You know, the solar is essentially heating my hot water. And, you know, when the batteries are full, I'll often set this up as a dump load. So rather than the solar panels being disconnected, it will just put the excess power after the batteries are full into heating up a tank of hot water. There are some other caveats with the electricity supply to this. Obviously, what you wouldn't want to do is turn your water heater on and forget you've put it on, and it will absolutely drain your batteries down to zero, which is not a good thing, especially if you're on old school lead acid batteries like I am. But to go through that, I will have to spin around how I overcome that. I'll just spin around and show you my electrical distribution box, which is over here, and I will have to get a screwdriver to take the case off this. Bear with me 1 second. So the cover is off here of my electrical distribution panel in my van. Excuse the mess, it is absolutely unfinished. It's near finished, but obviously none of the cable routing and tidying has been done yet. But there's just a couple of things I want to show you in this distribution box, which I think are kind of essential if you're going to be putting a 12-volt electric water heater in your boat, caravan, off-grid dwelling, whatever. And that is, as I sort of mentioned, an automatic shut-off relay. Obviously, what you don't want to do is turn your hot water on and forget you have it on, and you will definitely come back to your batteries reading 0.0 volts. So what I have done is the live feed, the positive feed from the batteries to the water heater goes through a relay, specifically a voltage sensing relay. If you're not really familiar what a relay is, it's basically an electronically actuated switch. Rather than a switch being finger actuated, a relay is a electronically actuated switch in most cases. And I will, if I can, zoom in on this guy here. That circuit board there is what's called a voltage sensitive relay. So I'm just going to turn the display on. So that is monitoring my battery voltage, and it's programmable. And basically, if my battery voltage I've currently set to, if my battery voltage runs down to 12.15 volts, it will actuate this relay, and turn off the water heater. So if I ever left my water on, it would just automatically turn it off when my batteries got down to 12.15 volts. Now, this electronic circuit board voltage sensing relay is only good for 10 amps, which is I can't put the water heater positive straight through this relay. It would eventually burn it out, because technically the 12 volt water heater could draw 25 amps. So this black box beside it is a automotive type relay, which is DC rated for 40 amps. So it's more than capable of taking the full amperage of the water heater. So what's actually happening is this voltage sensitive relay, when it actuates, it then actuates this 40 amp DC relay, which is where you'll see these thick cables here. These are the positive feed for the water heater. So yeah, I mean, this thing is programmable. I have it currently set that if the batteries get down to 12.15 volts, it will shut off, and then it won't turn the water heater back on until the battery voltage gets up to, I think I've set it to 12.35 or something like that. The other thing you would want to put into your system is, if I can zoom out a bit, is a fuse, which, if my camera mount will go down, this is that central one there, is the fuse that the water heater goes through. This is just a DIN rail mounted DC rated old school fuse. It's a 30 amp fuse in it at the moment. I probably will actually downrate it a little bit, but obviously, if you should have a fuse in your system which is close to the supply input voltage. I should also say at this point that again, the YouTube electricians might point out these two things either side of them are what you might see in your house. These are AC circuit breakers, basic B curve AC circuit breakers, and yes, there is DC running through these from two different appliances, which again people might flag out. In my own, I'm not advocating that you use electronic devices that aren't rated for a specific type of current or voltage to use them for that, but in this case I am. But a basic circuit breaker is a current sensing automatic switch, essentially. So it doesn't care if the current is alternating or direct. This breaker here, if it detects current going through it of more than 16 amps for a period of time, it will trip. Same with this 6 amp one. And these are AC rated trips, but they work perfectly fine on DC. I've even tested them myself. I've ran 7 amps through this one, and again it tripped out as to its spec sheet, as if AC was running through it. Same with this one. I ran 20 amps through that one, tripped out perfectly normally. So again, the water heater, I had one of these old school DC rated fuses, so I'm just using a DC rated fuse in the water heater. Other than that, is there anything else to go through with it? The only other thing that I will be doing, which isn't in yet, if I can get back up here, is obviously with the water heater, spin around, with the water heater over here, I'll have to zoom out, which my camera doesn't want to do. There we go, it's zooming out now. So this water heater is actually going to end up being just under the bed beside the kitchen. Going to be a little bit difficult to reach on a daily basis and see the power LEDs that are on it to let you know that you have hot water on, which is a little bit inconvenient. I will actually be running an LED to my control panel. Whoa, broke something. Over here, which will just be a hot water LED to let you know when you have the hot water on or off. Just to remind you, have it off. But one other thing I'm going to be doing with the distribution box here is this this relay I just mentioned, which is the automatic shut off if I accidentally leave the water heater on. I'm actually going to be pairing that up, which will be mounted on top of it with another relay, a Wi-Fi actuated relay, so which will, again, it'll be hooked into those two relays that are there at the moment, and it just means I'll be able to turn the hot water on and off through an app on my phone, which would be very handy if I'm out and about and forgot to left the hot water on. Or also I'll be able to set timers on it as well. So, if obviously the water heater can take quite a while to heat up water, and if you want to shower in the morning, what I'll probably do is set it to turn the hot water on at sunrise, or a little bit beyond sunrise, when the 400 watts of solar is working on the roof, and set it to start heating water at that point for 2 or 3 hours in the morning. So when I get out of bed in the morning, there will be a full tank of hot water. That's the only really additional thing I'll be adding to this water heater. That was probably quite a long video to explain how I literally just drilled out and put a 12 volt element into an existing water heater, but I thought some people might find the detail useful if they're thinking of doing a similar thing themselves. Again, as I mentioned, this do so at your own risk. I'm using electronic devices with DC when they're rated for AC, and again, it's modification of a pressure vessel, so if you want to do this stuff, do it at your own risk. This is just what I've done. Of course, any criticism and comments is welcome in the comment section, and I'll try and read all of those and make replies. And other than that, like and subscribe.